This is a demo of Spectraclass running on the Prism jupyterhub. I'm currently running the main Adapt Avarice custom Jupyter notebook. On this panel, we're looking at a data file here denoted by this image. On the left, you see the spectral panel, which shows the various bands of the data. Here, under the Data tab, we can choose the various different images. Within each image, we can choose a particular block or subtile of data here by clicking on various locations in the tile. Here we can choose whether to look at the raw spectral bands that I'm showing here, or we can flip over, we can look at the model data. The model data is actually the reduced data that is produced by the autoencoder and then fed into the learning procedure. Now here on the left, down below, we can click the slider to show the different bands of the hyperspectral data. And here we can navigate, zoom in, move the data around, and so on. Under the various controls, the first control is the Layers tab. Here we're looking at the Bands panel, which we can turn the Bands image on and off. And underneath the Bands panel is the base map, which is the RGB satellite map of the data. We can adjust the transparency of the various layers here with the slider. The markers, labels, and clusters layers will come into play when we start the learning procedure. So there's several ways in Spectraclass that you can choose learning training sets for machine learning. Okay, we'll now take a look at some of the point selection features. There are 4 different selection modes. The Explore mode just enables these tools for navigation in the spectral band panel. Now the point selection method has a number of different functions for exploring spectra at various points. First of all, if I enable the unlabeled class and then select points, what we see is the spectra of the selected points down here in the point spectra panel. So it enables me to explore the spectra, the various spatial locations, various pixels. And if you notice down here, in this mode, there are 2 lines drawn. There is a dark line and a lighter gray line. The dark line is the actual spectra. The lighter gray line is the reconstructed spectra as the output of the autoencoder method. The autoencoder maps the input to itself, and this allows us simply to check to see how closely it has reproduced the desired spectra. And as you can see, it's doing quite well. The reproduction is quite close to the original. Now, by selecting other various classes, then select points becomes a labeling operation. So for here, I will choose class 4 blue and then label some points here as water points. And then let's say we add some points here as class 2, some points in here as class 3, and say label some points right here on the boundary as class 1. Now, so next step, let's take a look at the embedding. Um, this embedding panel generates a 3D embedding of the data manifold. It takes, you can think of each point here as, say, a 400-dimensional space where the value at each point is the 400 bands of the spectra. Now you take those 400 bands, do a data reduction. There's actually two reductions. First, the autoencoder goes down to about 32 dimensions, and then this UMAP algorithm takes it down to 3 dimensions. So this is the 3-dimensional embedding of the data manifold. So for each point here, there is a point over here with the same coloring. And locality here is determined by spectral similarity. Now, if we reduce the point size and increase the marker size and maybe decrease the point opacity a little bit, we can see the markers that we just generated, which is useful way to look at the mapping between geographic space and the manifold space. So now the next operation we want to look at is the propagate operation, which takes us a particular class, and then when we hit propagate, it generates additional training samples by choosing neighboring points in the data manifold. So here, if we look at the class 4, as we hit the propagate method, it generates additional training samples. Similarly, for class 3, we can propagate that one outward, and class 2, where is class 2? Yeah, class 2 is a little hard to see. They're down here, and then similarly for class 1. Now, in the spectral panel, and in this view, it doesn't actually show the added points. In order to see those, we would have to go over and look at the labels panel. And here in the labels layer, we see the added points in geographic space. So the next thing we can do, now that we've defined a training set, is go over to the learning panel, hit the learn button, and this runs the learning algorithm. Now, what it's doing now is using the labeled samples to train a 2D CNN using supervised learning. The classification map is learned, so we now hit the apply button. Then we can go back to the layers panel, and by turning on the labels layer and turning up the opacity, we see then the generated mapping from the supervised learning algorithm. Looking at a fresh tile, we want to look at a different method for training set generation. In this case, we will start by clustering the pixels using k-means. I'll choose k-means, 8 clusters, hit the cluster button. That will generate a clustering of the spectra here, which we can view by turning on the clusters layer, turning up the opacity. So this is a generated cluster of the layer. Now, if we go to the selection panel and select clusters, we can then apply labels to the various clusters. Here also, it's often useful to in order to see what we're looking at, we can go back to the bands, reduce the opacity a bit so that we can see the actually see the underlying satellite image. And then when we turn on the clusters, we can also sort of reduce the opacity a bit to see what the clusters actually are. Let's we are selecting clusters. Let's label this, turn off the selector, label this cluster as water. And then these two clusters I'll label light blue for ice, and then just do a couple of types of landscape. Now, one thing I should mention is the thresholding operation. Let me turn off the clusters layer. Oh, yeah. I can reduce the threshold on the water layer because right here it was misclassified as water. So, see, right here, I think this may not actually be water. So I can reduce the threshold to uncluster those points. Then, all right, so we have water selected, and then we can go back and select a couple other clusters, like, say I'll call this class 2 here. All right, so we have some labeling done, and then again we go to the learning algorithm and train the classifier. This is now training a two-dimensional convolutional neural network. We can then apply the mapping and go back to the labels and view the mapping. So this is the learned classification of the various the spectral at each pixel. For creating training sets is by selecting regions. So here I've gone to the selection tab, chose select regions, and then you can select a class and then draw a polygon. So I am left clicking, left click, and then left click to create vertices, and then for the final vertex you want to right click, and that creates a polygon. And here are the graph for that particular, the set of spectra for that particular polygon. Now here, let's classify ice as this one. Left click, left click, left click, right click. And here the spectra, ooh, they're pretty close to water. Now let's say classify this area using class 2. Draw a polygon here, and again we see very similar looking spectra, and then maybe add this class here for this area. Use these regions to train a learning algorithm. Again, go to the learning panel, click learn. It's training a 2D CNN, which I've selected here. And so now it's learned, and I can apply the mapping, go back to layers, look at the clusters panel. look at the labels panel, and I can now see the mapping that was generated by that set of selected regions. I'm now looking at a data tile and the 3D embedding generated by hitting the embed button. Under the controls, I have using the select point option with the unlabeled class selected. Now I was going to do some exploration of the data manifold. In this case though, it's in order to see the markers, it's often useful to reduce the point size and the point opacity a bit and then increase the marker size. So now when I say if I want to see what region corresponds to this set of points here, I can select a point. Here is a selected point on this side, and then the corresponding point in geographic space is over here. So this enables me to explore this region, and apparently this area corresponds to this river down here. Similarly, if I look at this area, it corresponds here to this lake. And then if we look at the body here, corresponds to the landmass areas. Similarly, if I choose over here, I can see the corresponding point over here in the data manifold. Similarly here, of course, as I click around, I can see the various graphs of the various data points. Point selection. First of all, under layers, I make sure my marker layer is turned on. Under selection, I have select point. I go up here and choose class 4, and I will select some points here. Now, first of all, we see down here, the points selected are graphed. The bold graph is the point that I most recently selected. If I don't like these, I can right-click on a point and remove them. Similarly, down here in the graph panel, I can select one of these graphs, and as you can see up here, the point that is selected is labeled with the little X. Similarly here, if I'm not satisfied with the class, with this particular graph, or this graph looks like it should be belonging in a different class, I can choose a different class label here and then do reclassify, and now that one is reclassified now as green. Similarly, I can go down here and unclassify if I think a graph is an outlier and I think I should get rid of it.